This is our third video for week 4, still talking about triangle similarity. Now we're also going to be introducing something called flowcharts. And flowcharts is a way to organize your discussion or your proof or your reason why you're showing that two triangles are congruent. So we have to go through what we just went through in the last video and look at what pieces of it can we use to prove that triangles are similar. And we only have 3 ways triangles similarity to show that things are similar: AA, SAS, and SSS. Those three ways we're looking for. So let's look right here and see what we have. Let's do our we have this angle right here. It's congruent to that angle. That's a good piece of information. Here is another piece that we have this small side right here, the small leg. So this is the hypotenuse, and that goes with this hypotenuse. So this small leg is going to go with this small leg. And then our larger leg is going to match up here. I like to use colors because then I can see what lines up with what. So one thing is I can see that I'm going to find out if my proportions are the same. So I'm going to compare the 9 with the 12. So 9 with 12 reduces to 3/4. And then I started with this 9 to this 12. So since I started with this 9 on top, I have to start with this 12 on top. 12 over 16. Divide both by 4, that reduces to 3/4. So I have the same similarity. That's good. That's good news. So I can see that my two sides have the same proportion of 3/4 and my angle. And let's look at my little shortcuts. I have side, angle, side. If the two sides have the same proportion and the angle is between them, well, the angle is between them. See how these are the two sides and the angle's between them? So let's prove that everything is the same. So the first thing we said was that angle H was congruent to angle L. So angle H is congruent to angle L. And how is it that we know that? It was given. It was given in the picture. Okay. The next piece is that we used this 9 right here. So we said LK, L is the 90 degrees, matches with HG. HG, we know that that is 9 over 12, and that reduces to 3/4. So we're going to put in our calculation, and that was also given, but we had to calculate. We had to actually find that calculation. And then the same thing for the next one. This is LJ, and matches up. My L is the 90 degrees, and it matches with this H. So LJ matches up with HI. LJ, HI, and that was 12 over 16, which reduced to 3/4. And again, that was given, but we did have to do a calculation. Okay, we had to calculate. And so now that I know that those 3 pieces match up, I can say that triangle LJK is similar to triangle. There's never enough space to write in these boxes. So LJK, so I started with L at the 90 degrees. I went across the pink. So I'm going to go HIG. HIG. So we know those are similar. And how is it that we know it? Because of side, angle, side similarity. So that's our first proof. Okay, we're going to now look at the second one. And you can probably already guess what the pieces are going to be. So let's line them up. Look at, here's my small side on this triangle, and this is my small side here. All right, I have my large size, and this is the large size, and that means the next one is the medium one. So we're going to check all of these and see how they work out. So my small, I'll actually go color coordinate. The small is, I'm going to go 4 over 8. That reduces to 1/2. Okay, I'm going to do my large. Okay, I'm just color coordinating so you can see where these numbers are coming from. And I started with this bottom triangle on top, so 7 over 14 equals 1/2. And then for my last one, oh, is pink. Let's get the right colors. The last one is pink, and that one is 5 over 9, and 5 over 9, that doesn't reduce to 1/2, it stays 5 over 9. So I don't have all three sides congruent, so I would just write not congruent. That would be my reason for that one. Let's look at the next one. Okay, so again, we have two triangles on top of each other, and it's really good to kind of separate those out. So I have this is 9, this is 11, this is M, and I have this angle right here, S. That's my small triangle, and my large triangle, let's see, this is M, this is given to me, and I believe this is supposed to say 3 right here, so it doesn't, so I wrote it in there for us. This is 14, and this is, how did I get 14? 11 plus 3. 11 plus 3 is 14. That whole distance is 14. And so this whole distance is 9 plus 2.5, or 11.5. So 11.5. So now I can compare my sides. I have the small side, the 9 and the 11.5. And I have the large side right here. And then do you see what I see about the angle measurements? Check out the angle. This is M and this is M, so my angle is the same. So at least my angle is going to be the same, right? So we're going to go angle M is congruent to angle M, and that's given. Then what else do we have? Let's see. Oh, look, we have that this angle here, let's do a different color right here. We have that this angle here is congruent to this angle here, angle S and angle V. Angle S is congruent to angle V. So, and that was given, and I was given because of the arc marks. See the arc marks listed here? So since it was given, I can just put that. Now notice I proved that two angles are congruent. And remember, what are our three shortcuts? We have side, 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 side angle, side, and angle, angle, similarity. So we just need two angles here to prove. I have one here and one here. That's good. Now I'm going to use this piece. I don't need it. I don't have to check the ratios because all I need is that two angles are congruent. So I can say that triangle SMN is similar to triangle VMT, that's the large triangle, VMT. And the reason, because we just proved that two triangles were similar. So that's all we had to do for that one. Okay? All right. Now we're going to go back and look at our different pictures. For the diagrams, what are the lengths of the segments listed below? If it's not possible to calculate the length, explain why not. So we want to know, for number one, we want to know what's the measure of JK. So we're going to come back up here. This is JK. We know that for our things to be similar, it has the ratio of 3/4, okay? So this 3 comes from the small triangle, and this is my x, the unknown from the small triangle. So I'm going to have 3/4 is equal to x over 20. The 3 is from the small triangle, the x is from the small triangle. Okay, the 4 comes from the large triangle. So when I come over here, I'm going to set up a proportion. 3/4 equals x over 20. So that's going to set us up for solving this equation. So we're going to get 4x equals 3 times 20 is 60. Divide both sides by 4, you're going to get x equals 15. So our missing value is 15. Let's look at the next one. VT. Well, let's see. VT is from right here. Okay. So let's see if we can figure out VT. Well, we know our ratio, because we proved that these are similar, is going to be the same as 11 over 14. So I can do 11 over 14 equals, so 11 to 14 is to this over this. Okay, do I know what this is? No. So an unknown over an unknown. So that's not enough information. Like, we don't know what, because this side has to line up with this side if we're looking for that x, but I would need to know this piece of information. So I'm going to put not enough info. And I can shorten this by saying NEI. Not enough information. But for our next one, we do have enough information. We want to know what TN is. So we want to know what TN is. TN. Okay. So how would I do this one? I already said that it was 3. 9. Okay. So if I do 9 over 11.5, so we're going to, let's just see if it really is 3. 9 over 11.5, so what am I doing? How am I getting this ratio? I'm taking this, the pink, the small side, comparing it to this side, and then I want 11 over, let's say we didn't know it was 3. Let's put an X. Then that's going to be 11 over 11 plus X, that whole distance. 11, can't you see it all? 11 plus the unknown. But I said let's make it equal 3. So let's see what we get. We're going to get 11 times 11.5. 11 times 11.5 equals 9 times 11 plus X. So let's go ahead and solve this. We're going to get 126.5, I typed that into the calculator, equals 99 plus 9x. All right, so we're going to subtract 99 from both sides. I bet you that's supposed to be 20. I bet you that's supposed to be 27. But anyway, I think there's something inherently wrong with this problem, but let's just figure it out anyway. So that's going to be 25.5, right? Or no, 27.5? 27.5, I went the wrong way. 27.5 equals 9x. See, this shouldn't have been a 2.5. I bet you this should have just been a 2. If this was just a 2, it would work out perfect. But we divide by 9, and we're going to get x equals 3 point something. So there is something wrong with this problem, but the setup is what's important. Notice how we set up the ratio. 9 over 11.5. How did I get that? 9 over this distance, 11.5. And then compare it to this side. 9 is to 11, as 11.5 is to 11 plus the unknown. All right? Close enough. You are good on this stuff. The next page is all homework. Okay, I will be doing some live Zooms to walk you through this, but this is going to be your proof that you do on your own and a couple of practice problems. All right, have fun.